Hello, this is Eric Faldy from Fargo 3D Printing. We are obviously in Fargo. We have 3 time zones represented in the video today. I guess Central, and then I forget what the other 2 are called. But I think was it 10 p.m. in Cyprus? Something like that?
Yep.
And then 7 a.m. in Australia.
That's right.
And we are here with Zesty Tech, and I will let you guys do a little intro for yourselves.
Sure. So Nicola and I are Zesty Technology. We've, I guess, been collaborating for well over a year now. We backed the same Delta printer on Kickstarter previously, and through that experience, what a learning experience it was, because there was lots of technical issues, but we got our printer at least. We built some kits together, and then eventually we decided, we've done this stuff. Why don't we design a full printer? We think we can do a better job. And then as part of that process, we came up with the Zesty Nimble, which is what we're talking about today. Nicola, have you got anything else to say about that?
Yeah, hi, I'm Lieke Schepers, a Dutchman living in Cyprus, enjoying the life here, but boy, I don't see much of outside anymore because we're busy with this Zesty Nimble. It's been a long development project because there were some real hard technical challenges, but it really feels good to be able to finally launch this thing and together with Brian get it on Kickstarter. It really is a moment for us.
So I guess for people who aren't familiar with the Kickstarter, what is the Zesty Nimble? They may be familiar with it as an extruder, but what sets it apart from other extruders?
It's a remote direct drive, which means we put the stepper somewhere on the frame of the printer, and you mount the extruder directly onto the hot end or the head that moves. And because of that split, the extruder itself is extremely light. I mean, the Zesty Nimble is 28 grams or less than 28 grams. That's the lightest extruder ever. And because you have the stepper on the frame, you need a cable to go between the two to drive the extruder. And because we use a gear system to drive that, not only is the thing very light, it also has a huge amount of torque to push the filament through. So it's quite a unique construction.
And with the cable that we'll be shipping is around 95 centimeters, and some people think that limits the build height to be less than that. But what it means is you could mount your stepper in the middle of the build height, and then you can actually go up. So we're estimating you can do at least 1.5 meters of build height.
Okay, wow.
Yeah, for sure. Yeah.
So when you say it's geared, I guess where does the gearing come in? Because from what I see on the video, it looks kind of like it's a direct drive from the stepper motor to the linkage cable and then to the drive mechanism. So I mean, where does the gearing happen? Is that happening in the extruder, on the head of the printer, or is that happening in between the stepper motor and that linkage cable?
No, so you're right. It is actually inside the Nimble. So even though it's less than 28 grams, all of the gearing is happening inside there, and it's a 30-to-1 gear ratio. Okay. And basically rotational force gets of this way gets translated into rotational force this way, so that the hob can push the filament through the hot end.
So what sort of impact is there any sort of hysteresis that goes on? So if you're retracting filament and then pushing filament back out, is there any sort of slop in that?
No. Well, of course, with a flexible drive cable, you're always going to have some flex. That's part of the deal. But because you have a 30-to-1 gear ratio, that flex gets diluted by the gear ratio. So if you have 1 degree, it's divided by 30 by the time it gets to the hobbed wheel that pushes the filament. So any flex and any backlash or whatever you have in the system gets reduced 30-to-1 by the gear ratio. And for instance, on my Delta, I have a 1 millimeter retraction, and that's less than almost you have on a direct drive. So that really shows you how strong this is.
And in the Benchy print that I uploaded in our latest campaign update, I was using a 0.8 retraction. So
Yeah, that is pretty impressive. I mean, when you start thinking about, just the amount of flex that you have going on with a Bowden style extruder, and if you're trying to use any sort of flexible or semi-flexible filament, with a Bowden style, a 1 millimeter retraction is just unheard of. It doesn't happen.
I was running 8 millimeter retraction before I switched to the Nimble, so yeah.
Yeah, we have a CME CNC Orion, and yeah, that 8 millimeter retraction sounds about right.
Yeah. And also, you mentioned flexible filaments. The nice thing about this, of course, is that the filament path is completely enclosed because we have a breech loading system that clicks into the housing, and it encloses the complete filament path. So we print NinjaFlex like crazy. It works brilliantly.
So I know right before we started filming this, you're saying that some of the things on the campaign changed a little bit from earlier on. And so I hadn't seen what was in the earlier campaign, so in the first week or two of the campaign being live. So what changed in that 2 weeks to where it's at now?
So when we first launched, it was a larger unit. It weighed more, and the breech system was a 2-part system, something that we never really liked, and we were actually developing what is live now since before the campaign started, but we didn't want to announce it until we had done sufficient testing. Basically, we were doing lots of torture testing to make sure that it would work and it wouldn't break. And that's part of the reason it's taken us so long to get some videos online of the unit actually printing well. Not because it couldn't print well, just because we were too busy doing torture testing, basically. So,
for instance, torture testing, one of the things we did was reduce the temperature. And you're still forcing the filament through. That's like you're creating a jam, and see what happens and where does it start to break or where does it start to skip, and how strong an amp do we put on the stepper motor to get the stepper motor to skip instead of the filament to skip and so forth. So it really was an exhausting testing process. And doing that with all sorts of filaments. I've got about 30 different versions of filament to try out and force through this thing to see what works. And then the other torture test, of course, was just high-speed, long distance printing. So I just spent the whole roll in one day just flying it through the extruder to force it through as quickly as I could to see what would happen.
Yeah, that's a lot of throughput.
It's been fun trying to break this thing. Yeah.
And we've failed to date.
So yeah. I guess what level of I don't know if torque is the right word, but what level of pushing force or pulling force does the extruder have? I think I saw on the Kickstarter that you basically attached a hanging scale to it and we're pulling. And so I know one of the concerns that some people have that use printers and they use a very large spool of filament is whether there's going to be enough torque to cause the spool of filament to roll. I mean, some people have gone as far as to set up a motorized spool or like a despooling system. It doesn't look like that's going to be necessary with your extruder.
No, so with the current version, we're getting 6.8 kilos, was it, Lickler?
Yeah, we say we can pull at least 5 kilos, but we filmed it repeatedly going over 6 kilos. 6.8 was one of them, and I've seen 7.1 as well. But we play it safe, like the weight. It's 28. We weighed it, and it's 26.7, but we say 28 because when you go into production, it's always going to be a little bit heavier. So we play it safe. The same with the force that we can generate. We know we can generate 5 easy, so that's what we say we can do.
So on your Kickstarter, I don't remember the numbers, but how long have you guys been working on this project? You might have mentioned that already, and I missed it. But how many iterations as well on this project?
Oh God, Lickler, you're gonna have to answer this. I can't remember what we're up to now. So. Like 17 or something. Or?
Yeah, I think we're 18, version 18 now. But the problem is that since we switched to the ears, as we call it, the bunny ears, with the single breech block, I changed the numbering. So I shouldn't have done that but we spent about 1,700, almost 2,000 euros now on prototypes alone. just getting the housing done and so forth, and figuring out, because the tolerances are so tight, we couldn't print it ourselves, so we had Shapeways print the parts for us, and everybody in that supply chain now knows me very, very, very well. So that's been interesting as well. But yeah, we've handled a hell of a lot of filament that way, and prototypes. I think we're down to 20 now, at least.
Yeah, I think another really salient point in that is that all of the all of the plastic parts have been printed on Shapeways, and if you've ever seen a Shapeways print, they're not super smooth. So at the moment, we're using gears that are Shapeways, prints that are rough, and still it's working really well. So we're expecting an improvement in its operation when we have properly molded gears.
Yeah.
Which material are those, and what would be the end result for material after molding and all that?
Well, the Shapeways stuff is SLS nylon, and basically the injection molding is going to be nylon as well, but glass fiber reinforced, so to make the housing itself stiffer, and the breech block as well. The gears are going to be POM, which is a self-lubricating material, and it's super slippery by itself, and those are usually used for gears, for instance, in
desktop printers,
printers, copiers, that kind of stuff. And we found the perfect partner to do that stuff, who has a long history of developing gears and making gears from that particular material. So we're pretty confident that we have the right supplier and the right material to produce quality goods, because that's what we're aiming for.
I'll let John talk.
Well, I guess that was going to be my next question, Eric. Was just trying to ask. Okay, so what were you prototyping in? Then what are the next steps once you decide to go to a production run? Is the current iteration that the lighter one that's now on the Kickstarter page, is that the final one that when you go to injection mold it, that's the one that you're going to be cutting the tool for, or are there still some further modifications to be made?
It's extremely close to final. We've said that it's final, but we can see a couple of small tweaks that will possibly be doable before delivery that will make the overall size of the unit a little bit smaller. We're not expecting that it'll be a massive reduction in weight any further. We're pretty close to the limits of how much we can reduce weight, but there is a little scope to reduce the size. So. But none of the mechanical parts will change location or orientation, so that size change will just reduce the size of the box itself.
Okay, so I guess
we're tweaking the housing at the moment because the mechanicals are frozen.
Gotcha. So, number of parts in the final extruder. I know when we start looking at different Kickstarter projects, one of the things that always happens is when they go to production, if there's a lot of moving parts, a lot of different part suppliers, if one goes down, that disrupts the entire project delivery timeline. So I guess how are you working to address that?
So at this point, we only plan to have two suppliers. One supplier for the flexible cable, which is an Australian company who specialises in making flexible drive cables. And I go and visit them at their workspace quite regularly. And the other one will be making all of the other components for us. So I don't expect that we're going to get much in the way of lag times due to that. As far as the number of components in total, Lickler, have you got that off the top of your head?
Yeah, 10 to 11 parts. If you not counting all the standard stuff like screws, nuts, and bearings and so forth. Sure. But in real components that need to be made, it's 11 parts.
Okay, I mean that's not too bad. I mean that's very, and with only the two suppliers, it's a lot easier to keep track of a project like that with a two-person team than we've seen so many 3D printer companies that try and kickstart a 3D printer, and they have a team of 4 people, none of whom are very experienced in manufacturing, production, or supply chain management, and that's always what seems to be their undoing. Not that there was a bad design or not that it was a bad idea or a bad product, but that there just wasn't anyone with that kind of experience, or they tried to take on a little bit too much. So it sounds like your project is very, very manageable to do. So what is the, I guess
let me show you something.
Okay.
This has been my Bible. And
I have a copy as well.
We've reduced.
And I've like doggedly always is like simplify all the way through the process. So, and it's really salient that you raised that issue with other projects that have failed. The reason that we launched with the Nimble is because we were just like, first time doing Kickstarter, never done it before. Dealing with the logistics of building a printer with hundreds of parts versus something like this. It's just like, it was the common sense approach as far as we were concerned.
Right. Yeah, no, it definitely seems like you guys are going the smart way about it.
Mm.
So I saw a couple. Sorry, go ahead.
Yeah, I was just going to say we reduced the part count by a third, approximately. The first ones were about 25 to 30 pieces.
My question was about which printers this can be used on. Obviously, I'm excited that you could use something like this on a Delta bot, because the one thing I don't like is the Bowden style extruder, just because there's a lot of little problems that can come along with that. But which printers have you used this on, and I guess which printers do you guys use yourselves? And I guess the mounting bracket. I forgot that you guys said that you'd help with mounting brackets on your Kickstarter.
Yeah, we at the moment we're both using it on the same style of printer, Delta Boots Industries printer that we got through Kickstarter. That's a 1 meter tall Delta printer, and it works fine. The whole idea, the whole concept of the shape and the way we put the parts together is designed so that we are extremely flexible in positioning it on any printer that you can think of. Almost any printer. There's a few that are difficult because they have, for instance, completely closed and closed effectors with nice injection molded pieces of plastic covering it to make it look nice, but that means that you don't have space to mount an extruder. We have designed an adapter system that allows you to modify one little part to fit on the hot end you want to use, or on the position, or change the position slightly where you want to use it. And because the thing is ambidextrous, you can flip it upside down and use it the other way around. You don't even have to open it up to change any of the gears around. You literally just take the clamp off, which is a little hat that sits on the top, flip it 180 degrees, put the clamp back on, and you can use it. That means that you have an extreme amount of flexibility in positioning the extruder to fit optimally in the printer that you're using. And we have a list of 30 printers now that we're designing adapters for, or where it will fit on. And that simple Cartesians to Corexes to, there's one guy who wants to fit it on his big box with IDEX, so he's 2 printing heads and so forth. And he's now thinking of maybe fitting Cyclops or Chimeras on there. And our units are so small, 2 fit on top of a Chimera very easily, with about 6 millimeters to spare between the 2. And so he's going to make an IDEX that prints with 4 heads, you know, and with 4 nimbles. Sure, go ahead, no problem. You know, excited about that one.
Yeah, I mean, as Lickler said, with the adapter system, so Lickler's already designed quite a few adapter plates. I'm using the flat bottom plate on a Chimera at the moment. And you know, the Chimera is, I think, 18 millimeters between hot end openings, wasn't it, Lickler? Yeah, and yep. We've still got space between, so there's future capability to work with hot ends that are even closer together than what the Chimera is. And the other really sort of key point is the way we've designed it, and it was a specific design goal, is that because of that flexibility, we're able to, you know, if you start off with an E3D V6, for instance, and then later on you buy a Chimera, all you have to do is buy one more nimble. You don't have to make an entirely new unit. You know, the one you've got is still usable. You just add your adapter, and those adapters are actually things that you could just print with your FDM printer anyway. So it's not like you have to go and buy a new component. We'll make them available on Shapeways as well if people want to purchase them. But we've already made designs for some of those available and pieces so people can start designing their own adapters. I think the key difficulty we've found with designing adapters for people is when they're asking for it on a printer that they don't give any sort of drawings or anything for. So when we don't have one ourselves, that's difficult.
Yeah, I can imagine that would that'd be pretty tough.
Can I say one more thing, please?
Yeah.
Can I? Thank you. We also developed or developing a shroud that will fit on top of a diamond nozzle. So we have three nimbles sitting nicely together, but with a fan between them, and it fits wonderfully well.
I guess, John, did you have any more questions?
No.
Well, I suppose
I interrupted him with a question. So.
Oh no, that's perfect. So you guys are working on this right now. Is there anything in the pipeline for the future? Or are you just worrying about production for this particular project right now? What's next?
There's a couple of things. There's a couple of things. I'll talk about one and then I'll let Lickler talk about the others. So we're working in collaboration with David Crocker, who I don't know if he knows of Duet 3D. He was a co-designer of that. And he also developed a differential IR sensor for bed leveling. So we're working on a filament sensor that will be compatible with the Zesty Nimble as well as be usable in its own right. Obviously, we're focused on the campaign at the moment, so that work isn't detracting from the campaign. That's our key thing at the moment. But we are also working on other things. Lickler can talk about some of those.
Yeah, one of the advantage of the shape of the Nimble the way it is that we have all sorts of places where we can click things onto it. So, for instance, the filament sensor will just click onto it. I'm thinking of a little metal brush that will clear the hobbed wheel. You just extrude with that thing clicked in instead of the breech block. You have that thing clicked in. So there's a whole range of little adapters that are coming or that we're thinking about, or add-on tools that will fit onto the Nimble or can extend the Nimble in one way or another. The other thing is that this thing started as an extruder for our printer that we were designing. So that idea hasn't gone away. We're still working on that printer, although a lot slower now because most of my time goes into our time goes into the campaign. But that thing is going to be we're aiming to be just as innovative with that printer as we are with the Nimble, because we really want to make it move a step forward. And we see the Nimble as a launching pad to show that Zesty Tech is actually a company that can deliver creative engineering. That's our slogan. And we want to prove it so that our printer will fill the next step. And the other thing is we're working on a hot end that, again, is something that I haven't seen before. And I'm not going to give anything away because I'm really excited about the idea. But the difference between the hot end and the Zesty Nimble is that the Nimble we developed ourselves and we kept it secret till we launched. The hot end, once we have time to start working on it, I want to make that an open source idea. I want to join the group and say, look, guys, this is the idea. This is my first testing. I know it works. What do you think? How can we increase? Because both Brian and I feel open source is an important part, first of all, of the whole 3D printing environment. But in business these days, you cannot work any more profitable without being open source. And especially Brian, he's been in open source for years with Drupal.
Yeah. So I've been working with open source since 1996, roughly. So it's in my blood. Yeah.
So I'm sure people at home are going to be wondering about the price. Obviously, if you do the Kickstarter, I'm sure you can get a little bit more of a better deal. But what if you get a production going, what would be the off the shelf or off the e-commerce price, or is it something you'd figure out later on?
Probably figure out later on. We expect it will possibly be a little bit more. That the main issue that we've seen as the unit costs is pretty well set. It's the shipping that's really turned out to be more of a surprise than we expected. Hopefully, when we get to if there's enough demand and we get to scale, then shipping might come down, or we'll be looking to partner with sort of companies that retail on a continent by continent basis so that there's local suppliers for people.
Well, you can always talk to us if you need some help with that, but
Definitely.
yeah. So
Not a problem.
at the moment, are they going to be shipping out of Australia or out of Cyprus? Or
Most likely Cyprus.
Yeah, that's one option. The other option is to cozy up to a fulfillment center and use them to distribute it, and that probably is the cheaper option. But the problem is that we have great difficulty predicting what the split is going to be, where the nymphs have to be shipped to, and we guesstimated 40% USA, 40% Europe, and the rest of the world. It doesn't seem to be that way at the moment with the Kickstarter campaign, but so those choices kind of drive the shipping idea of where we're going.
anything else from you, John?
That's pretty much it.
Okay, well, nothing else from John. Where can we find you on social media? I know I found you guys on YouTube, but where else can we learn more about your project and the Kickstarter?
So we're at Zesty Technology on Twitter, and I think we're facebook.com/Zesty Technology. Correct me if I'm wrong, Lickler. Yep. That's the main channels we're using. We've got our own website at zesty.tech, which isn't as updated or as up to date as the Kickstarter campaign at the moment, but it's there. Has some info, but yeah, really busy. That's pretty much the main channels we've been using at the moment. So.
All right. Well, I don't think I have anything else either. Thank you very much. I know it was. I had to figure out time zones and everything. It was. I think Google and Skype actually have it figured out. I should have just looked on there. But thank you very much. I think maybe Lickla is going to go to sleep, and Brian still has a full day left. So.
Yes.
I still have an hour's work ahead of me, man. Come on.
I guess there's no sleep when you have a Kickstarter running.
Remember?
All right. Well, thank you.
It's a job. Yeah.
Thank you very much. Best of luck. We will keep track of that and look forward. You guys look forward to the video. I guess if you're watching it now, check out the Kickstarter, and I will see you guys later.
Cheers, John Eric. Thanks for having us.
All right. Well, thank you very much.
Bye, guys.
Just running over all of my cables.
We don't see anything, Brian.
What do you mean? You don't see me?
It's spinning,
No, just
loading.
a little spinning circle.
Yeah.
I don't know. I'll stop it and start it again. But
Oh, there's a picture.